Hello and welcome back to section 6.1 through 6.3. In this video we'll be going over example 1. So example 1 is this truss here, and we have been asked to find all the forces in the member, so all the internal forces. In the last video we discussed the method of joints as a way to find those internal forces. So let's look at that now. Alright, so I have the basics of the diagram drawn here. So we have joint A, joint B, joint C, joint D. Again, remember these are just pin joints. We have our external forces. I've gone ahead and labeled those as AY, CY, and CX. So again, this is a pin joint, this is a roller, and then we have an external force of 450 pounds also applied. So our first step in doing this is to break the problem apart. So we're going to, again, we need to expose these internal forces so that we can do some analysis. So at joint A, we can draw this force here. So again, remember, if your internal force goes away from your pin, that is tension. If it goes into your pin, it is compression. So in general, I draw all of my internal forces in tension, but you're welcome to use either one. So if I draw this one in tension, then on this piece it also has to be in tension. It has to be drawn equal magnitude, opposite direction, so that when I put these two pieces back together, they cancel out and I get a rigid body. If these two forces from A to B and B to A do not cancel out, then I don't have a rigid body anymore. Alright, so I'm just going to finish doing all of that. And then what I have here, oops, forgot to do B, is 1, 2, 3, 4. I have 4 different equilibrium problems. So these are particle equilibrium problems because I just have dots. If you remember back to particle equilibrium, you had 2 equations, sum of forces in the x, sum of forces in the y. And you can rotate your xy axis. So for instance, at A, you could make it point left and straight up. At D, you could actually have x pointed down this way and y pointed down this way. It doesn't really matter as long as you, within that diagram, you keep the same coordinate system. But you can change between the different, because these are basically 4 different problems that are all connected through these forces. So, given that, we have 4 equilibrium problems, which means we have 8 total equations that we can write. How many unknowns? Well, we have an unknown here. So this force is the same as this force, so that's not a new unknown. So we have 1, 2, 3, 4, 5. There are 5 unknowns in this problem, plus 1, 2, 3 external ones. Sorry about the lag on the camera there. So 5 internal forces and 3 external. So we only need to find the internal forces. So our strategy should be to figure out where to start. So we can do that by looking at each joint, because each joint is its own free body diagram, and count the number of unknowns at that joint. What we're looking for is a joint with only 2 unknowns. So at joint A, we have 1, 2, and 3. We do not know AY, so that is an unknown. At joint B, I have 1, 2, 3 unknowns. At joint C, I have 1, 2, 3, 4. So CY and CX both count. And at joint D, I have 1, 2, 3. I know the 450, so that is not an unknown. So I do not have any joints that only have 2 unknowns. So our strategy for right now, in the next example, I'll show you a different way to do this. But for right now, what we should do is we need to go find one of these external forces and try to get one of these down to 2. So if I redraw this triangle, so we're going to look at just the external forces. I have 450 acting up here. I have AY, I have CY, and I have CX. So if I found AY, this would drop down to 2. If I found CY, this would drop down to 3. If I found CX, this would drop down to 3. So I don't need to find AY, CY, and CX. Sorry, that should be an X. I only need to find one of them. So the choice should be AY, because if I find AY, then this will drop to 2 unknowns. So let's find AY. To do that, we could do forces in the Y, but then I have 2 unknowns. I have to find CY to do that. I don't want to find CY. Forces in the X, well, this doesn't exist in the X direction. So that takes us back to moments. So this is a rigid body, so we can do moments on the entire thing. So let's do moments about C, because then I don't have to find CY or CX, but I will find AY. So do sum of moments about C equal to 0. So then we get our 450, and it acts 4 feet away. And it is going to be positive because it'll go this way around that our joint or pin C there. Then we have AY. AY acts 8 feet away. And the way we have the arrow drawn will cause it to be negative, so it'll have a negative moment equal to 0. So then we solve this for AY, and AY becomes 225 pounds. So now I can go back up here and say, oh, well, now I only have 2 unknowns. And now we can start solving at joint A. So basically what's going to happen is we're going to cascade through these. We won't end up using all of them because we have more equations than we have forces to find. All right. So try to keep your work organized. So now we're going to go to joint A, and I recommend redrawing your diagram for each time. So we are at joint A. So in joint A, we have, so this is coming out from the joint, so it is a tension. It is the tension from A to B. And then we have this one also is going to come out. This is going to be the tension from A to D. And then we have this force, which was AY, but we now know what AY is, so I can just call this 225. And then we need to know what the angle is on this, and so if you look at it, you'll notice it's a 45-degree angle, so it's a 1 root 2 if you want to do the small triangle, or you could do 45 degrees in here if you like cosine and sine better. So now we want to find TAB, and so tension from A to B and tension from A to D. So if I work in the X direction first, I'm going to have 2 unknowns. If I work in the Y direction, I'm only going to have TAD. So let's start in the Y direction. Alright, so sum of forces in the Y, let's assume up is positive, equal to 0, and this is equilibrium. So I have the 225 pointed up, and then I have plus 1 over root 2 times tension AD, all equal to 0. So a lot of times these aren't very long equations, because there's not that many things going on. I solve this for TAD, I'm going to get negative 225 root 2. And this is in pounds, and then we would note that this is in tension, because that's what we assumed. Now the negative sign means that it is actually in compression. So we could also say that this is also equal to 225 root 2 in compression. Alright, so let's go back and look at what we know now. So we now know, oops, not done yet, jumping the gun here. So now let's go, so we now know TAD, so let's find TAB. So to do that, let's do sum of forces in the X direction, the other one we haven't done yet. So forces in the X equals 0, so I get TAB as positive, and then I'm going to get plus 1 over root 2 times our TAD, which I now know. It is, so you do not put in 225 root 2 here. You put in negative 225 root 2 because we have this drawn as tension here, as tension. So I need to put the tension value in, which is negative. So we put in negative 225 root 2. And this is all equal to 0. So the root 2's will cancel, and therefore we find that TAB is equal to 225 pounds in tension, because that's what I assumed initially. Alright, So now I know that. So I come back up to my original thing here. I have found this, and I have found this. Remember, finding this force is the same as finding this force. Finding this force is the same as finding this force. So I have found 2 of my 5. All right, so now I have nothing left at A. At B, I have 2 things left to find. At D, I have 2 things left to find. So I can go to either one. I'm going to go to B, but it doesn't really matter which one we go to next. So now we're going to go to joint B. Again, either one's fine at this point because they both only have 2 unknowns, so I can solve them with forces X, forces Y. So again, redraw. So we know that this is the tension from B to D, and this is the tension from B to C. And this is the tension B to A, so this is technically the tension from B to A, but we know that tension BA is the same as tension AB, which we found to be 225. So we would just put in 225 here. All right, so then, pretty quick math here. We do forces in the X equal to 0. And I know you can just see it, but I still want you to write the equations out so that if something were to happen, you would at least show me that you knew what you were doing. So you get negative 225, again I assumed right was positive, plus tension BC, all equal to 0. Therefore tension BC is equal to 225 pounds in tension. Do it again in the Y direction, so sum of forces in the Y equal to 0. I get tension BD is equal to 0. There's nothing else in the Y direction. So tension BD is 0. This is what we call a zero force member. In our next example, we'll actually look at how to find these graphically and then use them to simplify our problems. All right, so now we come back up here. We now know this and this. So the only thing we have left to find is there. So if I kind of update my information, I have 1 thing left here, I have 3 things left here, and I have 0 things left here. So we could go to C, but you have 3 things to find there. So you should go to D next because you have 1 thing left to find there. And we should only need 1 equation, so we should only need a forces X or a forces Y. So we're going to go to joint D, redraw it. So this is the 450, don't forget your external forces. This is negative 225 root 2. This is the tension from D to C. And this is our 0 force. I'm not actually going to draw it in because it doesn't actually exist. There's no force there. So what we would do is we can now do forces X or forces Y. So in the X direction, I have 1, 2, 3 things. In the Y direction, I have 1, 2 things. So I'm going to do it in the Y direction. So I do sum of forces in the Y equals 0. I'm going to assume up is positive. So then I'm going to get, let's remember our triangle here, 1, 1, root 2 for both of these. All right. I know it's a little bit small. So we get negative 225 root 2, and we want just the Y component, so that's going to be a negative 1 over root 2. So negative because it's going down. And so this is just the magnitude of the tension, and this is the direction. Plus tension DC times negative 1 over root 2, all equal to 0. When you solve this, you will find that basically these are going to cancel. So negative 1 over root 2 is going to cancel for both. Tension DC will be 225 root 2 pounds in tension. And with that, you have solved your problem. So in the next one, we're going to go look at 0 force members. See you then.